Hello. What you're seeing on the screen is a representation of data from 6 individuals who took part in a randomized trial designed to investigate the effectiveness of a drug treatment for patients with chronic schizophrenia. On the x-axis, you have the time that patients were followed up for, up to 8 weeks. And on the y-axis, you have the response that was recorded for each patient, which is a measure of their symptom severity. So high is bad and low is good. You can see 2 sets of patients here, one with the dotted lines who received the active treatment, and one with solid lines who received a placebo, a dummy drug. Now we want to understand the variability in these data, and the first distinction we need to make is between systematic variation and random variation. And the systematic variation here is between the 2 treatments. And you can see that on average, the solid lines are higher than the dotted lines, not totally, but generally speaking. And that's perhaps not surprising, because you would hope that the active treatment would produce lower symptom severity than a dummy treatment. Within the random variability, we've got quite a lot of structure, and it's a great mistake to think that random variability is just completely random without any pattern. So we can peel off various layers to this random variation. And the way to do that is first to look at the variation between patients who are on the same treatment. So there's no systematic variation. And if you look at the 3 patients who are on the active treatment, you can see that one of them consistently gives higher symptom severity scores than the other 2, although they're on the same treatment. So there's some variability between the patients, which is sustained over the 8 weeks of follow-up. You can also imagine, and this is suggested by the jagged lines, that there's some random variation in what you actually measure at each time point. It seems rather odd to imagine that all of the individual peaks and troughs in these lines are real changes in a patient's symptom severity. They're just chance occurrences of the particular exact time at which that measurement was taken. And then there's another, perhaps more subtle element of variability in these data. You can see that 5 of the patients did indeed provide data for the full 8 weeks of follow-up of the experiment, but 1 only provided data for the first 4 weeks. And it's not unreasonable to assume, and in fact it's true in this case, that the reason that patient stopped providing data, in the jargon, they dropped out of the study, was not unrelated to the medical condition that the trial was intending to study. And in order to really fit a model to these data and answer interesting scientific questions about the treatment of schizophrenia patients, you really have to understand all of these different layers of random variation in the data. It's not just pure noise. Thank you.